The multimeter, your essential HVACR diagnostic tool. A multimeter is crucial for HVACR technicians. It's a versatile tool for diagnosing electrical issues in heating, ventilation, air conditioning, and refrigeration systems. Using a multimeter effectively can save you time and money. It helps pinpoint problems quickly and avoids unnecessary component replacements. This guide will cover the basics of using a multimeter for HVACR diagnostics, focusing on voltage, continuity, and resistance measurements. Whether you're a beginner or a seasoned professional, understanding these fundamental measurements is essential for accurate troubleshooting. Before using a multimeter, always consult the manufacturer's instructions for your specific model. Safety is paramount. Always double-check your multimeter settings and connections before taking any readings to avoid potential hazards. With a good understanding of your multimeter and these essential measurements, you can confidently diagnose and repair HVACR systems. Measuring voltage, powering up your diagnostics. Voltage is the electrical potential difference between 2 points. In HVACR, it's crucial to check voltage to ensure components receive the correct power supply. Step 1. Set your multimeter to the appropriate AC or DC voltage range. Most HVACR systems use AC voltage. Step 2. Connect the red lead to the positive point and the black lead to the negative point or ground. Step 3. Read the voltage displayed on the multimeter. Compare this reading to the expected voltage for the component you are testing. Practical tip. When measuring voltage across a switch, make sure the switch is in the on position. For thermostats, simulate a call for heating or cooling to get an accurate voltage reading. Common mistake: forgetting to select the correct AC or DC voltage range can lead to inaccurate readings or damage your multimeter. Continuity testing, ensuring the flow. Continuity testing checks for a complete electrical path. This is useful for verifying switches, fuses, and wiring. Step 1. Set your multimeter to the continuity mode, usually indicated by a sound wave or diode symbol. Step 2. Connect one lead to one end of the component or wire you are testing and the other lead to the other end. Step 3. If there's continuity, the multimeter will beep or show a reading near 0. No continuity will result in no beep or a high resistance reading. Practical tip: when testing fuses, it's best to remove them from the circuit for accurate results. This avoids any parallel paths that may give false readings. Common mistake: not realizing a component needs to be isolated before performing a continuity test. This can lead to inaccurate results due to other components influencing the readings. Resistance testing, uncovering hidden problems. Resistance measures the opposition to electrical current. It's crucial for checking motors, sensors, and other components for potential faults. Step 1. Turn off the power to the circuit you'll be testing. This is critical for safety and accurate readings. Step 2. Set your multimeter to the appropriate resistance range, ohms. Step 3. Connect the leads to the component's terminals, noting the reading. Compare it to the expected resistance. Practical tip: when measuring resistance, ensure the component is isolated from the circuit to prevent other components from affecting your readings. Common mistake: measuring resistance on a live circuit can damage your multimeter and is dangerous. Always de-energize the circuit before testing resistance.